Okay, here we are at section 1.6. So we've got the last couple sections here for this video, and we're going to look at the programming process to start out. So here you can see all the little steps that we have as we go along. So defining what it's supposed to do, visualizing how it's gonna, run on the computer, using the design tools. And so some of the tools we have the, hierarchy chart, flow chart, pseudocode. If you took CIS2, then you would have seen flow charts, maybe some pseudocode. So you've got that piece in there. So you're looking for logic errors, writing it out, compiling it. Go to the next slide, correcting errors, linking it to an executable file. So running it, and again, correcting anything along the way. So repeating these steps as many times as you need to do, and then validate. Does it do what it was supposed to do? So this is just a really quick look at programming process, and you'll get to do all this kind of fun stuff as we kind of roll along throughout the semester. So you'll see it just kind of becomes second nature as you're rolling through and writing code. So anyway, so we got that. Just to give you an example of a hierarchy chart over here. Typically you'll see flowcharts, and you'll see some examples of flowcharting in our book. Our author likes to use flowcharts, but we can also use pseudocode. So pseudocode, if you're familiar with that or you've seen it in the text, it's where you're just kind of writing it out, jotting notes as to how you think it should work. So code according to the way you see it and in your language. So if we look at this example for pseudocode, here's our task that we have at the bullet point. So we have our task to add two numbers. So just really simply, how might this work? And so here we go with the pseudocode. So we're going to say start, and then we're going to say get two numbers. So we need to get the first number, get the second number. We're going to add them and print the answer, and then that's the end. Okay, so really simple. There's no, right way. There can be lots of wrong ways, but there's no really a right way, honestly, or a wrong way if we're really looking at it. So it's just a matter of getting it down and knowing that hey, we need to do some things. Like for example, just looking at this, I could add another line in here that after Adam, I have to store it. I didn't talk about declaring variables. There's a lot of things that you can do in it, but pseudocode, just getting it out there and going, okay, this is how this works. Okay, so I don't know. That's basic pseudocode. All right. So rolling right along. If you were to write your own pseudocode for a program that calculates the total of a retail sale, including a subtotal for sales tax, what would that look like? Okay, so just take a few minutes. I'm going to pause the video and just on a little sheet of paper or in Word or something, write out pseudocode for how you think this program might work. So calculating the total of retail sale, including a subtotal for sales tax, okay, and what would need to be displayed. All right, so I'm going to pause the video and I'll come back and just, well, for me it'll be just a second, but for you guys, it might be a little bit longer. Okay, so hopefully you paused the video and you had a chance to go ahead and attempt this, just for your own practice. Okay, so I'll give you an example of, a pseudocode, what this might look like. This is a little bit more detailed. So here we go to sales tax detailed pseudocode. So here we have input retail sale, and you can see on here with the name. So with a prompt, and meaning it's they're going to ask for it. We'll talk about the backslashes to there and commenting on lines and sections in your code later on. Then we're going to input the sales tax rate because we don't know what the sales tax rate is. And then you're going to take the tax amount is going to equal the retail price. You see our operator here with the asterisk here. So we've got this little star, and then we say times the sales tax rate. And then the sales total is going to equal retail price plus the tax amount. And then we're going to display those three things. Now, again, there's lots of ways that you could do this. This is just one way of doing the pseudocode. Okay, so something that you understand that as you're jotting notes down about how am I going to make this program work? What do I need? A lot of times people will declare their variable names along the way and decide like, hey, I want to use this as a variable name. So you see that listed there. But again, not to say that yours is wrong. It's just or right. It's just there's lots of ways of doing it. All right, so it's just a matter of getting the thought process out there so you can play with it. Okay, so let's look at a couple other things. Let's look at another scenario here. So let's look at this. So coming up with at least 3 questions, and we walk through a scenario. So suppose one of your friends who paints the inside of houses has asked you to develop a program that determines and displays how much paint is needed to paint a room if the length and width of the room are input. So you are lacking information to write this program. What are at least 3 questions you would need to ask your friend before starting the project? Okay, so again, I'm going to pause this, or you guys need to pause it too, and then we'll come back together and see what we came up with. All right, so just some example questions that might need to be asked. And the list could be go on forever and ever and ever, but these are just some things that we might need. So, what standard ceiling height should be used, and are we going to input that? So, how tall are they, right? So, let's see, how many square feet should be subtracted out for windows and doors? Or do you want this information input since it could vary by room? Okay, so these are just some ideas that students came up with. Are the ceilings also to be painted or just the walls? How many square feet will 1 gallon of paint cover? That seems like a pretty standard question. Maybe you know that already. Let's see. How many coats of paint will you use, or should this be input? Okay, so just an example of some questions. Again, you have lots of may have lots of questions for this. Again, no right or wrong answers here. Just trying to find out information so you can write the program correctly. All right, so let's look at a few other things just to wind this down. All right, so looking at this, so predicting the output. So looking at this problem, so the variable sum starts with the value 0. So add 10 to sum, add 15 to sum, add 20 to the total, display the value. So take a second, pause this, and see if you can tell me what the answer is. And hopefully you paused it and you were thinking about it for a second, and now you have an answer. So let's see, what do you think it is? Well, I'll give you the answer here. The answer is 25. So adding 20 to the total does not apply to sum. So you have to be really careful with variable names. So if we talk about this in here and we're saying, hey, sum, and then all of a sudden you have this total in here. First of all, if you haven't declared total, this will cause an error. But if you have declared total, then it'll add 20 to the total, and you'll just have that in there. But the value of sum would be 25. Okay, so let's try this again. So another one here. So variable x starts with 0, y starts with 5, and what is the value of y at the end of the run? So pause this, come up with the answer, and then hit play again. Okay, so hopefully pause it and have come up with an answer now. And we will see our answer here. So display the value of y at the end of the run, and it should be 7. And just kind of for your information, there is a video link in the PowerPoint, so you can click on that link in the PowerPoint, and it will take you right to the author's video on how to calculate this and the thought process behind this. It's actually problem 33 in the back of the chapter. Okay, one more. This is actually problem number 34, and I'm going to pause this, or you should pause this, and see if you can figure out an answer, and I'll give you the answer just as soon as you hit play again. All right, so I'm hoping you paused it and you have an answer now. So if you haven't hit pause, do it right now. I'll give you a shot. Anyway, okay, so here we go with our answer here. Blah, blah, blah. At the end, the value of k should be 28. Okay, so again, that's number 34 in the back, so you can check that out. Okay, so that's the end of this particular section. That's the end of the PowerPoint slides and the end of this particular chapter.